All right, in Module 17, we're going to take a look at some safety considerations that we need to adhere to in the data center. So let's start out by identifying different safety considerations for environmental health and safety. All right, so as the number of data centers are going to increase, so does the impact on the environment. So some of the negative impacts are going to include power consumption, carbon footprint, and electronic waste generation. So with the power consumption, we're going to generate a lot of excess heat. And to manage that heat, we're going to have to use cooling, which is going to have to use a lot of electricity. So we know that that impact has a lot of legitimacy. And as we can see, the number of data centers are continuing to grow. Some new technologies like smartphones, data analytics, IoT devices are all going to increase the need for for data centers, which will increase the need for electricity. Now, one of the electric demands, what we've seen is the demand for electricity is growing now for the first time with any significance since sometime in the 1970s. So we need to have additional sources of power, like wind, solar, hydro, and that kind of thing. And so we will continue to see an increase in demand for electricity that goes along with the growth of data center construction. All right, so carbon footprint is definitely going to have an impact, right? Because that shortage of electric power has had more data center, more electrical supplied by burning fossil fuel, which will increase carbon emissions. All right, electronic waste, of course, as we dispose of more of these electronic devices, it is going to generate more electronic waste, and it can have an impact on the environment if it's not disposed of or recycled accordingly. So how do we measure or implement measures to reduce that negative impact? Right, so one of the things that we want to do is we want to do an energy efficient design, energy efficient cooling, and adhere to government and agency regulations related to data centers and that increased demand for electricity and carbon footprint and all of those things. Now, overall, data centers are safe places to work, but there are some certain workplace hazards which all workplaces have, and we can take measures to avoid those workplace hazards. We're going to have the environmental health and safety compliance. The data center operations team is going to get the right people involved for their environmental health and safety. They're going to enhance awareness, and they're going to prioritize safety training. So we want to identify safety considerations for life safety. So one of the things we want to do is we know that drawing large amounts of power can lead to fire hazards in the data center, right? Fires can spark from digital equipment, cables, air conditioning equipment, floors, ceilings. Anything that's combustible can potentially be a fire hazard, and that can create havoc and cause irreparable damage, right, to data, property, and human lives. And this isn't just a data center issue. Any workplace environment that you're in will have fire hazards. It's just the nature of modern life. We use a lot of electricity. We use fire to heat, by burning things like natural gas or propane. We do have fire hazards that surround us. All right, so to mitigate fire, we want to have a fire safety system. It's going to be related to our data center design. It's going to include detection capabilities. So can we detect if there's fire, and can we suppress the fire once that is detected? And it's going we're going to go into some detail here on having fire safety at 3 levels, right? The building level, the room level, and at the rack level. So with fire detection techniques, we can reduce damage to the facility by using things like spot detectors, air sampling, smoke detectors, and spot heat detectors. So spot detectors are going to be used for fire detection. They're going to activate when smoke reaches that device. So it tells us that they can operate on two principles: ionization or photoelectric light scattering. And we can install those in ventilation ducts so that if that smoke is coming through the ventilation system, that spot detector can recognize it and identify where that that is coming from. All right, the second thing we can use is we can use an air sampling smoke detector. So the air sampling smoke detector is going to be made up of a distribution network that covers areas that it is protecting. They're going to continuously extract air from the room, so they're going to take air in, they're going to send that extracted air to the smoke detector, and that smoke detector can detect and give you an early warning of a probable fire hazard. So if it's detecting smoke, it can raise the alarm. The third technique is a spot heat detector. So we can mount that on a ceiling or attach it to a sidewall up near the ceiling, and it can activate when the heat in that space crosses a predefined limit. Okay, so tells us that there are three types of spot heat detectors. One can be a fixed temperature detector, which would tell you that, hey, we've reached whatever that temperature may be, 180 degrees, 200 degrees, I'm not sure what it is. I'm just pulling those numbers out of thin air, but we're going to have a base number that says once we reach this number, kick it on. The rate of rise detector is going to detect when that temperature in the facility is increasing at an abnormal rate. Okay, so it's the rate of change in the temperature over a given period of time. And then we can have rate compensation detectors, which are going to detect fire when the temperature around that equipment reaches a preset value. So that's going to be around the setup around the equipment, or the temperature surrounding it, whereas the fixed temperature detectors are usually going to activate when a piece of equipment reaches a preset temperature. So they kind of do the same thing, but the sensors are located in different locations. All right, any fire system is going to come with a fire suppression system because, hey, that's code. So the building is going to need to be built to a specific code specification to reduce major damage to your facility by basically dousing the fire. So the fire suppression system, we can have clean agent, sprinkler system, or a water mist. Clean agents are non-water based fire suppression that basically are designed to starve the fire of oxygen, which will then put it out, because remember that fire has that three triads, right? You need a heat source, you need a fuel, and you need oxygen. So if we can pull one of those out, the fire will go out. So clean agents are used a lot in data centers. They're released into a room from a control panel, and the nice thing with the clean agents is they don't harm the electronic components when they're in use. Therefore, we can salvage the equipment in the event that that system goes off. Sprinklers, on the other hand, are most commonly used water-based fire suppression type. These can cause significant damage to IT equipment. But we should know the difference between the pre-action and the wet systems. Okay, so the pre-action have valves that open and then flood the sprinkler piping. So the piping is dry. There's no water in the piping unless the suppression system is activated, versus a wet system which contains water in the sprinkler piping at all times. So if you think about it, right, we can have, that wet system can be a larger risk to the IT equipment in the event that the lines corrode and start to leak, or we get some water leakage at a joint or something along those lines. So the dry systems are a little bit better. All right, water mist suppression. It's a newer technology. And it works by atomizing the water droplets into it atomizes those water droplets into a non-conductive mist. Okay, and it doesn't cause significant damage to the IT equipment because it's a misting and not a flooding event. So I'm not super familiar with these water mist suppression systems, but I'm only basing my understanding on what I've read about them, what I've seen in videos as well. All right, identify safety considerations for personal protective equipment, or PPE. So how do we mitigate risk by utilizing PPE? So at work we're going to have safety is going to contribute to our availability, of course. We want to have a low number of incidents as far as safety, so we're going to reduce the operational risk, and we want to increase the uptime of the data center. Now, let's go in and look a little deeper to see how personal protective equipment can help us with that. All right, so the Occupational Safety and Health Administration, or OSHA, in the United States indicates that PPE refers to items typically worn by a worker to provide protection from recognized hazards. So PPE can come in many different forms. Here's a few examples. It may come as head and face protection, right? Eye protection in the form of, say, safety goggles or safety glasses, torso and limb protection, hearing protection, foot protection. I can give you some examples. When I worked in a manufacturing facility, right? We had to have foot protection, steel toe shoes. We had to have eye protection. You had to wear safety glasses all the time. And in certain areas, if you worked, you had to wear hearing protection. Those were usually noisier areas. So that's how PPE can mitigate risk by using barriers in the form of clothing and that kind of thing. All right, so here's some PPE that we would typically see in a data center. Earplugs, right? Data centers are noisy with all those fans. Safety glasses, goggles, face shields in the event that you're working in an area where something might be projected or expelled from a piece of equipment. Think about HVAC system, for example. If somebody's working on that in something, because we're dealing with fluids that are under pressure. There's that. Hard hats for drop safety. Safety shoes, which are steel toe shoes, so you don't drop something heavy on your toe, on your foot. Insulating rubber gloves with leather protectors if you're dealing with electric stuff. And anti-static wrist straps, cut-resistant gloves, and the list goes on there. All right, there's risk of using too much or too little PPE. So when we're looking at the appropriate level of PPE, we want to assess and anticipate the potential risk for doing that job or task. So the organization will typically have gone through and done an evaluation for each task and determined what the appropriate level of PPE is. So we're going to use the appropriate amount to help safeguard employees. If we don't use proper PPE, right, the employee's exposure to injury can increase. Here's an example. You may go in, have your safety engineer goes in, does some decibel readings. Okay, how loud is it? Then they look up some of the PPE standards that OSHA has, for example. OSHA says after this certain decibel level, hearing protection has to be used. So we can go in and monitor in the data center where the decibel levels exceed a place and then require that employees use hearing protection in those locations. All right, now it does go in and talk about, hey, if we have you use too much PPE or the wrong kind of PPE, it could impair your ability to move or see if we're doing this incorrectly. All right, certain risks that are specific to working in a data center. There's 4 categories here, right? One of the risks is working with electricity. One is heavy item lifting. One is water cooling maintenance. One is cooling maintenance. All right, from an IT standpoint, working with electricity, we aren't going to deal with a lot of the more dangerous levels of electricity. Most of the electricity we're going to be dealing with is the incoming electricity into the IT equipment, okay? But our HVAC people, for example, are going to be dealing with a lot more. Our maintenance department people who deal with our electrical work, making sure that our generators and all of that other stuff, they're working with a lot more dangerous electricity, for example, than an IT worker. But since the data center is going to use high voltage, right, the data center is going to find that it's important to have, use a formal work order before beginning work on any electrical equipment, and use proper PPE that's going to insulate that employee from electrical shock when they're working on any equipment that's over 50 volts. All right, heavy item lifting. This definitely applies to IT work because servers, let me tell you, are heavy. UPSs are heavy. So we want to make sure that we're using appropriate footwear in those situations. Safety-toed shoes so that if you drop something on your feet, you're not breaking your toes or breaking your foot. We want to use correct lifting techniques, right? Keep your back straight, use your legs, that kind of thing. Avoid lifting loads directly off the floor. Avoid carrying that heavy equipment over long distances. Use lifting equipment where it's available. And it tells us to wear gloves to avoid finger injuries and stress. Most of this will be in the safety training for the data center, okay? Because workplace injuries related to heavy lifting are significant, causes a lot of expense for employers in workers' compensation issues. So they will have as much as they possibly can in there to reduce the impact of lifting heavy items, assuming you follow the processes and procedures that are laid out by the company. All right, water cooling unit maintenance, definitely not something that's often done by IT staff. This is going to be done by the HVAC staff at the data center, but understanding how data center operations work, these are safety risks that we need to be aware of. All right, so there's going to be electrical, mechanical, hydraulic, chemical, and thermal risks associated with these, right? So they need to be aware of isolating the system that they're using on, the right devices to use, using safety shoes, using proper eye and face shielding to prevent from, liquids, chemical gases, acids, flying objects. We're going to wear PPE to protect against that. All right, computer maintenance. This is definitely going to fall under the IT staff piece of work here. All right, it says consider all risks, primarily electrical and heat. And guess what? I've gotten shocked before. I've gotten burns before from working on computer equipment. Use proper PPE. Use proper safety procedures when you're working on this. One of the things that is commonly called for, if you remember back to like CIS 140, we talked about anti-static wrist straps. It safely grounds you, right? It keeps you from building up static electricity on your body and then converting that into static discharge into a piece of equipment which can damage it. All right, what does the employer need to do? They need to train the employees on correct use of PPE. So we need to make sure that everybody knows how to use the PPE and that PPE is available to everybody in those situations. So anywhere that we're working with electricity, heavy items, water cooling unit maintenance, or computer maintenance, we need to routinely discuss PPE use. And you will see posters and placards in work areas that warn you, hey, PPE is required in this space. All right, safety consideration for risk assessments, and we want to make sure that we have very important IT resources for an organization. To meet those demands, we need to be continually operational and available. So to do this, we need to have systems, procedures, and processes in place, right? All of these are always susceptible to risk, so we need to do a risk assessment, right? So data center is going to be have potential. It's going to try to identify our upfront risks or unidentified hazards that could happen. So we want to do a risk assessment, right, to assess what's most likely to happen, where these risks will most likely have a negative impact, and then develop a risk management plan, right, to try to cover all of the risks that we can identify in our risk assessment. And if we identify it, how do we neutralize or how do we provide employees with a list of mitigating activities and procedures? All right, when we assess risk for the data center, we want to take the risk considerations into effect and determine how likely is this to happen, and how is it going to impact the data center if this risk materializes. Okay, we can take a look at internal and external risks. So in external risks, floods, earthquake, power grid failure, pandemic, supply chain failure, cybersecurity breaches. These are things that are all outside of our control, and technically they happen outside of our facility. Internal risks, right? Fire, loss of life or injury due to accidents. These are things that can happen inside the facility. Non-usage of standard procedures by workers, right? They're not following the correct processes for these things. Internal data theft, skill unavailability are internal risks. All right, power failures. We've already talked about power failures quite a bit and how do we mitigate those, so I'm not going to spend any extra time here. Fire, we've talked about fire risk and we've talked about fire mitigation strategies. Again, in this module, we're just looking at these as they are related to safety. All right, natural disaster, natural calamities. How do these happen? How do we mitigate them? We have talked about these before. We're going to have equipment in there to try to minimize the level of disruption that they can provide. All right, security, internal and external breaches, physical and logical. That means somebody physically trying to get into the facility or logically coming in through our networks. And how do we mitigate these? Most data centers are going to have, they're going to have security cameras, and they're going to have DVRs. They're going to record this all the time. We're going to have proper cybersecurity and data security in place to try to make sure we are not leaking any information that we shouldn't be. All right, other risks. So we can get other kinds of risks, right? Rolling out new technologies, different managements and resources. A lot of these issues are going to relate to non-compliance or operational safety. We need to mitigate these risks by training employees, giving refresher trainings on how to do their jobs, how to do things on a daily basis to mitigate risk, and then by actively monitoring and looking for potential issues that might crop up or breakdowns in our processes. And that gets us to the end of Module 17.